Hello everyone and welcome to this lecture on univariate and bivariate analysis. These two methods are essential for extracting insight from data. Whether you are a student, a researcher or a business professional, mastering these concepts will give you a strong foundation for more and advanced analytics. Let's start with quick refresh. Univariate analysis. Univariate analysis focuses on one variable at a time, and bivariate analysis studies the relationship between two variables. Both are fundamental in descriptive and inferential statistics, and they are crucial for understanding data patterns and relationship. For example, univariate analysis could look at the distribution of students' height in a class. Bivariate analysis, on the other hand, might explore the relationship between hard studied and exam performance. Next, we will see about the univariate analysis, descriptive statistics. Univariate analysis summarizes a single variable. For central tendency, we use the mean or average, the median or middle value, the mode or the most frequently used value. For dispersion, we use the range, which is difference between the largest and the smallest value, variance, which measures spread around the mean, standard deviation, the square of variance, coefficient of variation, which allows comparison of variability across dataset. Together, these measures describe the distribution and the spread of one variable. Next, we will see about the univariate example descriptive statistics. Here we will see about the bivariate analysis. Bivariate analysis explores the relationship between two variables. It helps us to see if a positive relationship or a negative relationship or no relationship at all. For example, consider the relationship between daily temperature and ice cream sales. Okay, temperature and ice cream sales. Okay, we know that if the temperature is high, the ice cream sales will also be high. If temperature is low, the sales of ice cream will also get low. Okay, this is the concept or relationship between the temperature and the ice cream sales. This shows the positive correlation. The main goal is to understand the associations and in some cases predict one variable using other. Next is bivariate key relationship. To measure variable bivariate relationship, we use different methods. First one is correlation coefficient. Pearson's R relationship in numerical data, Spearman's rho for ranked or ordinal data. Chi-square test to check the association between two categorical variables. T-test or ANOVA. T-test compares the mean of two groups, while ANOVA compares the across three or more groups. Similar linear regression predicts the value of dependent variable based on one dependent variable by creating a linear model. Choosing the right method depends on the type of data and the research question. Next, we will see about the visualizing univariate and bivariate data. Visualizing make analysis easier to understand. For univariate data, histograms shows numerical distribution, bar chart display frequency of categories, pie chart shows proportion of a whole, box plot reveals spread and the qualities. For bivariate data, scatter plots shows relationship between two numerical variables. Cross tabulation display joint distribution of categorical data. Grouped bar chart compare categories across another variable. Good visualization turns raw data into clear and meaningful insight. Next, we will see about the interpreting bivariate result. Okay. Interpreting result requires more than just calculation. Effect tells us how strong a relationship is beyond and just statistical significance. Degree of freedom and test statistics guide us in testing whether the result are due to change. And the context and data type also crucial because the same statistical method may not apply to every data set. So interpretation is about both number and context. Next is real world application. Univariate and bivariate analysis are widely applied across fields. In market research, univariate analysis looks at customer demographics like age, while bivariate analysis examine how income affects the purchasing. In healthcare, univariate analysis studies age distribution of patients, while bivariate analysis compares recovery time across the treatment. In social science, univariate analysis focus on individual survey response, while bivariate analysis compares opinion between demographic groups. These applications shows how powerful these methods are in solving real world problem. Summary and key takeaway here is: univariate analysis describes one variable at a time, focusing on general tendency and dispersion. Bivariate analysis study relationship between two variables, helping us finding association and some make prediction. Hope you understand this video.